Hello. Hello.
Hello.
Yes.
Hello.
Hello. Yeah. Could you hear me?
Yeah. Can you hear me?
Yeah. One sec.
Fine.
Hello. Yeah. Could you hear me now?
Yeah, I can hear you. I'm just sharing my screen.
Okay. And also, I have asked for the answer for the last uh, the last class we discussed one question, right? I need a written answer of that question. I have already told the
Which one?
uh, last class we have discussed one question, right? I have already sent that question to the WhatsApp group. Um, it's
Okay,
like by
about
method
that.
of choice and
Yeah, the
and
class
by
question.
graphical method. And yes, please, I need a written answer of that question.
Did you try after we discussed how to solve that question?
Yes, I tried, but I don't know whether it's the right answer or not. And also the graphical method, I'm slightly confused on how to get it right. So
Are
could you
you
please?
getting same answer since in graphical method and using method of joint and
No,
method of
graphical
section?
method, I'm fully confused. I haven't got it yet. I just lost on midway. So
Okay.
yes, so
Okay,
if you could,
no problem. I will send you the solution there.
can you send it by tomorrow, please?
Tomorrow, I will try if possible. If not possible tomorrow, then I will send by day after tomorrow morning.
Okay, fine. Okay, that's okay.
Okay.
Shall we start now?
Signal speed. Is it
Yes.
visible?
Yeah,
Okay.
yeah.
Okay. So the topics which we shared with me, that is that is basically the kinematics of
Okay.
particle and then kinetic and dynamics.
Yeah.
Okay.
Yeah.
So basically, if we check with the kinetic parameters, given that is displacement, initial velocity, final velocity, and uniform linear acceleration.
Mm,
So between these four parameters, there
mm.
is two, three relations. Okay.
Okay.
The
Yeah.
relations are also written there,
Mm.
and using those relations, we can solve those tests of
Okay.
kinematics.
Okay.
So, so it is given like suppose your displacement is yes.
Mm.
So first of all, what is displacement?
The distance traveled. I have got an idea of these things, but I just
Oh,
need one more one pack, like a pack, like what do we say? Uh, a lecture that touches all the portion and go on. I know all these things, but just
okay.
one, yeah, I just need to get refreshed by all these terms. That's all. So in 1 hour
Okay.
lecture, if we could cover the whole portion, that would be great.
Okay. Okay. Just check and cover all these things.
Mm.
So, okay. So we have displacement. Then U means the initial velocity.
Initial velocity,
V
V
is the
final
final one, and A is the acceleration.
acceleration.
Acceleration that is uniform linear acceleration.
Okay.
So, and suppose the time is t.
Mm.
So the relation Suppose if we want to find out the final velocity, that is
Mm.
going to be equal to u plus at.
Okay.
That is one of that one is getting like what do we know that acceleration what that is dv dt.
dv by dt. Yeah.
And suppose your dt means what? That is the temperature time change. So that is t, and dv is your final
Hey.
velocity minus initial velocity.
Yeah.
So from this expression, we can get this one that v is equal to at plus u. So v is equal to u plus at. Okay.
Okay. Okay.
Then we have s equal to u plus half at at square. So from the first equation, what we can check that if you know any three values between these three, so we can find out the fourth one.
Okay.
Similarly, here also you can check here we have total four parameters S, U, T, and A. So if we know any three, we can find out the fourth one.
Fourth one. Yeah.
Now here you can check that is the relation between U, V, A, T. This one U, S, A, T. Right?
Yeah. Yeah.
Now V square is going to be equal to U square plus 2AS.
Mm.
So here also you can check it is between U, V, S, and A.
Mm.
Okay.
Yeah.
So you need to check in your questions what are the parameters given. So based on that, you need to use the equation.
Mm.
Okay.
Okay.
And the last one that is given as this is given as U plus V into T divided by 2.
Mm.
So that is also you can check it is between S, U, V, and T.
Okay.
Okay. Now one more thing here, the value of A. That means A is here positive acceleration.
Mm.
Okay.
Mm.
If it is given in your question like we are having deceleration. Deceleration means the acceleration is negative in that case. Okay. So what is the whatever value is given here? Suppose it is given the suppose a ball is deaccelerated at a for a value of 25 meter per second square. That means our A value is 20 minus 25 meter per second square for that.
Okay.
So that sign is also important that you need to use in this equation here. Okay.
Okay. Yeah.
These things are basically based on kinematics. Here,
Mm.
there is no sign of dynamics because dynamics means what? We talk about dynamics. Dynamics means there should have external force.
With external force.
These things here, we don't have any force. These are simple means after giving some force. Suppose if you have uh, a inclined plane with that, and here you have what this muscle or block we can call it.
Mm.
So this one, suppose it is given, it is moving. So it is given that initially it is velocity 0, and after some point it moves this distance. So the distance is s here, and at this point the velocity is v. Okay, and
Okay.
also given that traveling time from here to here. Okay, so you have u, v, and s. So u, v, s you have. So if it is asked to find out what is the traveling time t, or if it is asked what is the value of the acceleration, those things you can find out from here.
Yeah.
From this equation, equation 3. So it is based on u, v, s, and so u, v is given, so you can find out the value of a.
Mm. Yeah.
Using this using equation 4,
Mm.
you have s, u, v. So you can find out what is the time equal.
Yeah. Okay.
So this kind of question you can get from kinematics.
Mm.
Now, if we talk about dynamics means there will be some external force, first of all. So this force can be like, uh, what we can say, some external force directly if it is given, or if you apply some brake, then the inertia force. Inertia force means what? The force of the body.
Hmm.
Then the frictional force, then gravitational force, all these things.
Okay.
So suppose we have one block like this, and we apply some force F from this side, and it is given that the surface and the block at that connection will have frictional coefficient or coefficient of friction mu. Okay.
Okay.
So what we can say, and it is given that the block is moving. Okay.
Okay.
So if the block is moving, that means what? This coefficient of friction that is going to be kinematic coefficient of friction. Okay.
Okay.
Mu has two targets. That is
Hmm.
mu s, that is static friction,
Hmm.
and mu k, that is kinetic friction. So
Okay.
mu is means when if you apply some force but the block is not moving. In that case, so the block is in static position, so we need to use mu s. And if it is moving, then we need to use mu k. Okay.
Okay.
Now, suppose it is given that it has some mass in. So mass m is there. Now, suppose it is given, it is asked to find out what is the acceleration of the block.
Hmm. Okay.
So that one, how can we solve? So for that, we are going to use Newton's law of motion.
Okay.
So I can check here. Here you need to use Newton's law of motion, D'Alembert's principle of conservation of momentum, and conservation of energy. Okay, we'll discuss all those four things.
Okay.
So first of all, Newton's law of motion, that is very simple.
Hmm.
What do we know? That if Newton's law of motion, is we need to use second law, basically.
Hmm.
So if we draw the free body diagram of the block,
Okay.
so first of all, in the positive x-axis, so this is our x, this is y. In the positive x-axis, we have the force F. Yeah.
Yeah.
Okay. Now, using D'Alembert's principle, also it will connect our D'Alembert's principle. What does we get from D'Alembert's principle? Means if a body is moving, so suppose the body is moving in the positive x direction, suppose then in the opposite direction, we have the inertia force.
Hmm.
And the inertia force is equal to the mass of the body into the acceleration.
Hmm.
So D'Alembert's principle says that inertia force that is equal to mass into acceleration.
Okay.
So that will be in the and D'Alembert the inertia force that will act on the opposite side of the motion.
Okay.
Okay. So our m into a, that is our inertia force that will act in the opposite direction.
Hmm.
Now, due to the mass, due to the mass of the or due to the weight of this block, we have the downward force here. That is a weight that we can
mm,
call M into G, right?
yeah.
So that is the gravitational force. And
Okay.
the block is connected with this surface. So the surface will apply some force here. So that is known as the normal force.
Normal.
And one more thing, as we have here friction is given. So friction, what we know that friction acts in the opposite direction of the motion.
Yeah.
So if the block is coming on this side, so in this direction we have the frictional force, small one.
Yeah.
Okay. So that is the complete free body diagram of that block.
Mm,
So after that, if the free body diagram is done, then the next step is we need to write the equation of equilibrium. That means so summation of fx is equal to 0 and summation of fy is equal to 0.
yeah.
If we do that, so from here, if we do for first, let's do if x. So in the positive direction, we have capital X, and in the negative direction, we have small f and ma, right?
Mm, yeah.
So f is equal to f plus ab. Okay.
Mm, okay.
And what is f? What summation of f1? The positive y direction, we have n, and negative um, y direction, we have m into g.
Energy.
Right?
Mm,
So that n minus mg is equal to 0, or we can write a is equal to m into g. Right.
yeah. Yeah.
So what is our unknown actually? That a we need to find out.
Mm,
The acceleration we need to find out. The mass of the block we know. G obviously we know. The given force that also we know. So what we don't know that is that a and f.
mm,
So if n and a total three unknowns,
mm,
but then we have two equations.
yeah.
But we have one more equation, that is the relation between friction force and normal force. That is F is equal to mu into N.
Okay.
That here we need that mu. That means if it is given that the block is in the static position, then we need to use mu s. And if it is given that it is moving, then we need to use mu k. Okay. So that mu value is also given. So that F is equal to your mu k into N. Now your N is equal to mg. So you can write your F as mu k into m into g. Right?
Yeah.
So now if you put F in the first equation, then capital F is equal to mu k abc plus m. So from this equation, all the values are known. So you can write, you can find out your value of.
Okay.
So that's it. This is the uh, method to solve a problem of dynamics using Newton's law of motion and D'Alembert's principle.
Okay.
So basically, to solve one dynamic problem, we have three methods. So dynamic problem we can solve using three methods. The first one is using Newton's law that we just discussed. Second one is conservation of energy. And third one is conservation of momentum. So Newton's law of motion that we have discussed. So we'll discuss conservation of energy and conservation of momentum. Then we will change if we have some time, then we can discuss one or two problem to how to solve using these three methods. Okay.
Mm, okay.
So, so Newton's law of motion here. Now conservation of energy.
Mm,
So conservation of energy means what? That means from the term itself, we can understand that total energy
this is
is
constant.
constant. Fine. So what is the total energy? That
Total
means
energy, kinetic energy plus potential energy.
yes, the kinetic energy plus potential energy that is constant.
Okay.
So what we can see that between point 1 and point 2,
Mm,
the total energy is constant. So Ke at point 1 plus Pe at point 1 is going to be equal to Ke at point 2 plus Pe at point 2.
yeah.
Actually, there has some more energies like energy of the body itself and activation energy, then nuclear energy, all those things. But whatever those things are not going to be changed from position 1 to 2. So we can eliminate from both sides. So we have
Okay.
this equation of. Now, what is the formula for kinetic energy?
Half mv squared.
That is half mv square. And potential energy,
Mgh.
mgh. Good. So that means at first position, we need to find out half mv square and half mgh. Need to do the summation. And the second point also, then if we equate them, we can find out what is the unknown level.
Okay.
Okay, that's it. And like one thing you can see from here, from the first one, from Newton's law, here you can see here we have find out the value of acceleration.
Mm,
Okay. Ultimately, we find out the value of acceleration. But here you can see here we don't have any term related to acceleration.
mm,
So if it is asked to find out that at means during this journey or operation, what is the acceleration? How can we find that position 1 we have? So the mass is constant, so we can neglect that mass. So we can write in this way. This one, right?
mm,
Now, in this equation, at position 1, suppose at position you know everything. Means what is the velocity E1, then what is the height H1. Those things you know.
mm,
And it is given that at position 2, here you suppose you know the height. So that means
okay.
H2 is given to you.
Okay.
Right? So using this equation, you can find out the value of V2.
Okay.
After solving, so you know V1, V2, and you know H1, H2. That means you can use the equation from the kinematics. So U, that is initial velocity, here we have V1. So U, V is those things you know, so you need to find acceleration. So using this equation 3, you can find out the acceleration.
Okay. We have to give the values of v2 and h2 in that equation. Yeah.
Yes, that V2 square is going to be equal to V1 square plus 2A square. S is
Okay.
the
And
displacement.
this is
So we need to find out that using H1 and H2.
okay.
Okay. Suppose it is given that in an inclined plane, we have one block. So here the height is given. That is supposed to be H1. Here
Mm,
the height is given. That is suppose H2. So what is the displacement? That is the displacement. That shortest distance.
okay.
Right.
Yeah.
So that is you can calculate. from this right angle triangle. This is your S, and here it is your H1 minus H2, and the angle here that we will know, that theta. So from here you can calculate S. Right.
Okay.
So
Yeah.
ultimately you can find out the acceleration.
Okay. Okay.
So when if we want to discuss about conservation of momentum. So first of all, what is momentum?
Mm, Mass into
Momentum. Yeah.
velocity.
Just tell me.
Mass into velocity.
Yes, this momentum is nothing but the mass into velocity. That's
Mm,
it. Now what we know from Newton's second law, that F is equal to ma,
mm,
right? That
Yeah.
we know from Newton's second law.
Yeah.
Now how can we write A? That A is our dB/dt, right?
Mm,
So A is equal to m into dB/dt. So from here, what you can write? F dt, that is equal to m into dB.
mm,
Right.
Yeah.
So if we integrate that, so suppose at time t1, velocity is v1. At time t2, velocity is v2. So f into t2 minus t1, that is going to be equal to m into v2 minus v1.
Yeah.
So if the value of force is given to you, and
Mm,
it is given that at time, suppose given that at initially, so initial condition means what? That means your t is equal to 0
mm,
or t1 is equal to 0, you can say. So suppose it is given initially your velocity is 0, or suppose velocity is given some value as speed, suppose.
mm,
So if it is asked to find out the velocity at t2, suppose that t2 is equal to t, so f into t, that is going to be equal to f into v2 minus v.
mm. Okay.
So using this equation, you can find out your v.
Okay.
Again, you can check one thing, that here you know, so v2 is equal. V2 means your final velocity v. V1 is your initial velocity u, and that T1 is 0 as initial velocity and initial condition T1 0, and your T2 is T. Then using the first equation of kinematics, that A is equal to U plus AP. So from here you can calculate your A.
Okay.
That's it. That's all about this method. Now let me check if impulse is there or not. The impulse is not clear. So we can um, check one thing that is given here. So the energy method. So this is the method, that is fine. So suppose after solving all those things, if it is asked to find out what is the total work done.
Total work.
So if it is asked to find out the work done. So
Okay.
what is the work done actually?
Force into
That is
displacement.
force into displacement. So the value of force that is given to you that you know, and that case you can calculate. So from here you can find out the work done.
mm,
Right. And then if it is asked to find out the power required, so power required is suppose B. So power is work done per unit time.
okay,
So those things you can calculate. Or we have one more formula for power, or actually that is known as instantaneous power.
yeah,
It's going to be equal to the value of force into velocity.
okay,
These things are here in the note. And one more thing is about impulse. So
impulse,
impulse basically that is we get from the conservation of momentum. So suppose impulse that is for conservation momentum we get this impulse. So suppose the one ball, then it is suppose it has mass m1, and initially at this point it has velocity v1. Okay.
okay,
So velocity v1 means suppose it is moving in this direction,
okay,
and here you have one more mass, one ball suppose which has mass m2, and suppose it is going with velocity v in
mm,
this direction, positive direction if consider. Okay.
okay, yeah,
Now when this ball is going to have an impulse, or is going to be as one, what we can say, when you can hit this ball, when our v1 is greater than v2, the velocity of the first ball, if it is more than the second one, then only it can hit the second one. Otherwise, suppose v2 is more, so it will go faster, then it will never hit the first second one. Right.
hello,
Hello.
yeah, sorry, I couldn't hear that the network was breaking, the voice was breaking.
Uh, Suppose your first ball is having mass m1 and velocity v1, and second one was mass m2 and
M2
velocity
and
v2. And both the balls are moving in the same direction, suppose in the positive x direction. Now, when the first ball can hit the second one, when the velocity of the first one is more than the second one, right? At that case only we have the collision. Otherwise, suppose v2 is greater than v1, or suppose v2 is equal to v1. Okay, let us first consider for the v2 greater than v1. So what will happen? It will move faster. So this ball is going to be, this ball never can hit the second one, right?
mm,
Or if the velocities are equal, then also the distance between them, that is going to be fixed. They are not going to be collapsed. Okay.
okay, yeah,
So v1 is greater than v2. Now suppose, so after some points, it will hit. So after time t,
mm,
so both these ball will be in connection. So suppose it is moving also in this direction, it is also moving in this direction. So suppose at that point, it has mass m1 and velocity v1. It has mass m1 and velocity v. Okay.
mm,
Then after that point, what is going to happen? If the first one hits the second one, then the second one will will move little bit distance due to this collision,
Yeah.
right?
Yeah.
So suppose finally it has velocity v4 and it has velocity v3 after the collision.
Okay.
So what we can see, so at this point we have total momentum. Momentum is what? That is mass into velocity.
Velocity.
So there it is m1 v1 plus m2 v2, right?
Yeah.
And here m1 v3 plus m2 v4, right?
Yeah.
Now, due to the conservation of momentum, these two values are going to be equal.
Okay.
So if it is given in your question that suppose masses are given for both the balls. Now suppose initial velocities are given v1 and v2. Now it is given that after the collision, velocity of any one ball that is provided to you. So you can find the other one.
Okay.
Right.
Yeah.
So that's the use of
Log.
conservation of momentum.
Okay.
So that's all. So now let us discuss one question using all these methods.
Okay. Hello. Hello.
Now,
Yeah, I could hear now.
just think that have one car
Okay.
and suppose it has weight of W.
Okay.
Suppose over it, suppose a man is there
Okay.
who has weight of small w, suppose.
Okay.
Now, suppose initially the man sits there on the top of the car and the
Mm.
car is moving with a velocity v naught, suppose. Okay. Now it is given that
Mm.
if that man moves in the opposite direction
Mm.
with a velocity small u,
Mm.
then what is going to be the increment in the velocity of that car?
Okay.
Fine. Just one thing. If you write the mass. So suppose the car has mass of m1 and the man
Mm.
has mass of m2. So initially, so you can check one thing. We have to find out what is the increment in the velocity of this car. Obviously, if the man moves in the opposite direction, that car velocity will increase, first of all.
Okay.
So that things we can actually we can calculate. So as all the things are related to velocity and mass only, then we can use the conservation of momentum here.
Okay.
So that also we need to understand. We point due to Newton's law of motion. So Newton's law of motion means it related to acceleration directly.
Okay.
Newton's law is related to acceleration guidance. So
Okay.
when we need to find out acceleration or acceleration is given, we need to find out other things. Then we're going to use Newton's law. If it is
Mm.
based on height and velocity, then we can use conservation of energy.
Okay.
And if it is based on only velocity, then we can use conservation of momentum.
Okay.
So for this, so initially, what is the momentum?
M1.
The momentum is m1 plus initially the car is moving with velocity v naught and the man sits on the car.
Mm.
Initially he is not moving. So he also have the same velocity. He also
Okay.
has the same velocity v naught. So m1 plus m2 into v naught.
Mm.
Now, now what is the final momentum? So it is the initial momentum. So final momentum, finally,
Mm.
the man is moving in the opposite direction and the car is moving in the positive direction. Oh,
Yeah. Yeah.
so for the man, we need to find out what is the value of momentum, and
Mm.
for the car, also need to find out the momentum.
Okay.
So for the car, what will happen? It has the mass m1, right?
Mm.
And what is the velocity now? The velocity has increased by some value. Suppose as increment is delta v, that we need to calculate the delta v, right?
Yeah.
So finally, the car has the mass of m1 and velocity is v naught plus delta v, right?
Mm.
And for the man, the mass is m2, and what is the velocity? What is the velocity? Now, at the final stage, the velocity of the car is v naught plus delta v,
Mm.
right? But the man is moving in the opposite direction with the velocity u.
Yeah.
So he has the velocity of v naught plus delta v minus u.
Okay.
Is if the car is fixed, suppose the car is fixed, or suppose the man is running on the floor, then he has only velocity u, right? And as he is moving in the negative x direction, so that is going to be minus. That's it. But he is on the car, and the car is moving with the velocity v naught plus delta v. So what you can see from the road that he is moving with the velocity v naught plus delta v minus u.
Okay.
So that's the velocity of the man. So v naught plus delta v minus v. So now if we equate this initial and final momentum,
Mm.
from there you can find out the value of your delta v. So that means m1 plus m2 v naught, that is going to be equal to final momentum is summation of these two.
Mm.
Let's see. From here you can calculate your delta.
Okay.
That is of course impulse and momentum. Now let us solve one question based on conservation of energy.
Okay.
So suppose initially a particle is placed at the point A here,
Okay.
and this track, suppose that is suppose here. Okay, not a maybe is here. This is suppose B. Here it is C. So this
Okay.
A, B, C, suppose it is frictionless.
Mm.
Now, if a particle is here, suppose. Now, if we push this one slightly, so what will happen? It will follow this path, right?
Mm.
So it may possible that it will follow up to this, then again it will come this side, again come. That means there will be some oscillation. So
Okay.
that things is not in our syllabus. So what we need to check that it will move in this direction.
Mm.
Now, what we need to find out, suppose at point A, for point A, the height is 1 meter. And for point B, suppose the height here, that is 0.5 meter from the ground.
Mm.
Now, check what is the velocity of the particle at point B. Velocity at point B. That we need to calculate.
Mm.
So how can we calculate that? So here you can check one thing, that we have height and we need to find out velocity, right?
Yeah.
And that means height and velocity, that means we need to use conservation of energy. Means if we use conservation of energy, then we can get the result directly.
Okay.
So at point A,
Huh.
what is the kinetic energy? So that means what? At point A, kinetic energy plus potential energy, that is going to be equal to kinetic energy plus potential energy at point B. That is our conservation of energy. Right.
Okay. Yeah.
Now, what is the kinetic energy of point A?
Half m v square.
Okay, half m v1 square surface. Now, here we have a little boost. So if it is given that, we just boost this one. That means what? So at point A, velocity is 0.
Okay.
So at V A is 0, or we can say what V1 is 0. So this one is going to be 0. Right?
Mm. Mm.
What is the potential energy at this point?
mgh
M into G into H. So M into G into height is given as 1 meter.
1 meter.
That H actually, okay, let us write here 1.
Mm.
And what is the kinetic energy at point B?
Half mv square.
Is so half m square. Suppose at point B, we have the velocity v.
Mm. Yeah.
And what is the potential energy here?
mg into 0.5.
0.5. So from here, m cancel out. So G is equal to v square by 2 plus 0.5 G. So generally, that is, if it is mentioned, that is fine. Otherwise, you need to use 9.81.
9.8. Okay.
So from here, you can calculate your
V.
fine. Now, one thing that you need to clear there that uh, that age actually that should be of any one reference. Means for A, if you take the height from this reference, suppose this is your reference,
mm,
then for B or for C also, that should be your reference. So we need to take the height of point B from this reference only.
okay.
It may possible that in your question it is given that the height is here 1 meter, and suppose this one is given you that point, suppose this 0.4 meter it is given.
Mm,
Like if it is a written question, it is given that from 1 meter height, a ball is going downward value of zero point 0.4 meter. That means what? That this distance that is zero point 0.4 meter.
mm,
So that distance is 0.4 meter.
okay.
Right. So whenever you are going to take a reference for any for PA, which is the reference for the point B also, you need to take the height for the same reference for point C also. Okay.
Okay. Yeah.
So that's it about the conservation of energy. And for conservation in the Newton's law, we have you discuss one problem that is this one. Using this one, we can find out the acceleration. This kind of question you need to solve. And angular things are there in your syllabus or not?
Which one?
Angular displacement, angular velocity, angular acceleration.
Uh, is that there in that? I think yeah, it might be there.
Because it is not written here, but it may possible. Depends. Because if it is there in your syllabus, then it's fine. Otherwise, we don't need to discuss those things. Actually, that is not very difficult thing. Suppose it is
Uh,
asked for your angular case.
uh,
Just compare. So in
uh,
linear case, we have the displacement case.
uh,
In angular, we have the angle theta.
okay.
In linear case, we have velocity g.
Yeah.
Suppose v come later. Suppose initial velocity is t. So here initial angular velocity is omega 1.
Okay.
Suppose here finally we have velocity g. So here it will be corresponding omega 2.
Mm,
And here we have acceleration a. So here we have angular acceleration alpha. Okay.
mm,
So in linear case, we have the relation of v is equal to u plus kt. Right?
mm,
Similarly, here also we can write similar relation that omega 2 equal to omega 1 plus theta into, not theta,
alpha into t.
alpha into t.
Okay.
Similar kind of relation. P square is equal to u square plus 2as.
Mm,
Here also omega 2 square is equal to omega 1 square plus 2 alpha theta. Okay.
yeah.
So the remaining two equations also we can write in the same way. That's it. And mm, for conservation from Newton's law also, the Newton's law would have m efficiency, not this. So in Newton's law, we know F equal to m right?
Mm, yeah.
In case of angular, so it is angular, so here it will be torque instead of force. Okay.
Mm,
So torque is going to be equal to, instead of m is the mass, here we have the moment of inertia, I. Instead of a, we have alpha.
yeah.
This kind of relation of that is equal to equal to T is equal to I alpha.
Mm,
Then, like from here, if we write F is equal to m into dv dt, so here we have also similar things that T is equal to I into d omega. So you can check if you have angular cases, then you can mm, solve using these things also. So initially, what you can do, just go through these dynamics things and the kinematics things also, these equations, and how to solve using the um, Newton's law of motion, and then conservation of energy and conservation of momentum. If you have questions, then just try to solve. If you got stuck in any question, just share that to Aditya, then uh, I will send you the solution of those questions if you have
okay.
any doubts. Okay.
Oh, yeah.
And about the trust question that I will share by tomorrow or day after tomorrow morning. That's
Okay, fine. Yeah, that's okay. Yeah. The
oh,
test question,
oh.
so have you already got the question, right? I have already shared it in the WhatsApp group. So,
Yeah, yeah, I have the question.
yeah, the question. Okay, fine, fine. Yeah, okay. If
Thank
possible, please share tomorrow or else
or
morning.
day after
Yeah,
tomorrow morning.
yeah. Yeah, so please do a step by step answer so that I could see all the steps and go through it without having the direct answer. For the drawing, that's okay, but others, if more explanatory answer, then that would be more helpful.
Yeah, for those, okay, I will try to write all
Yeah,
these tips.
okay. That's it for today, right?
Yeah, that's it for today. So you just practice using these concepts, and if you get any doubt, then just share those questions with Aditya. I will try to send you the answers.
Okay, okay. Thank you, sir.